This problem is a great example of how to use the 3, 4, 5 right triangle. More on that a little later. This is a coordinate geometry problem and it doesn't involve the direct application of a formula, so you would want to draw out a rough sketch. We have the x and the y axis, and there's a circle whose radius is 5 units and the center is at 1, -2. Let's say this point is 1, -2, and this is our circle. We need to find out which of these points, there can be more than one correct answer, are on this circle. Look, there are different ways to approach this problem. You know the coordinates of the center, you know the radius, therefore you can find the equation of the circle. And then try and fit each of these points into the equation of the circle to find out which are the ones that work. You could also apply the distance formula between each one of these points and the center and pick the ones that give you a distance exactly equal to 5 units. But that's going to take you time. Let's see if there is a better way to do this. There are 4 points on the circle, 2 at the same level as the center and the other 2 right above and right below the center, whose coordinates are really easy to find out. These 2 points are going to have the same y coordinate as the center. So this is going to be something, -2. And you go 5 units below 1, so that's going to be -4. And we already have a -4, -2 over here. So this point works. What about this point? This point is 5 units above 1, so this is going to be equal to 6, -2. And we do have a 6, -2 over here. Cool. This point has got the same x coordinate as the center and is 5 units above -2. And therefore that's going to be equal to 3. Do we have a 1, 3? No, we don't. And this point is going to be 1, 5 units below -2 is -7. We do have a 1, -7. Wonderful. So by now we already identified 3 of the points that lie on the circle. For the rest, we are not going to apply the distance formula or do something that's going to take us time. Instead, we are going to make use of the 3, 4, 5 right triangle. How come? Let's find out. Let's say we have a point over here on the circle. Obviously, that's going to be 5 units away from the center because it's on the circle. Now, if we go ahead and complete this right triangle, if this point out here has got integer coordinates, well, all these 5 points do have integer coordinates, then that would mean the base of this triangle and the height of this triangle must be integer numbers. And the only way that could happen is if this is a 3, 4, 5 triangle. So either this has to be a 3 and this has to be a 4, or this has to be a 4 and this has to be a 3. And the same logic applies for every other point on the circle, because they're all 5 coordinate points away from the center. Therefore, all we need to do now is take each one of these points one at a time, find out the difference between the x coordinate of the point and the x coordinate of the center, and the difference between the y coordinate of the point and the y coordinate of the center. If one of them is a 3 and the other one is a 4, then the point is on the circle, otherwise it isn't. Let's start. The difference between -3 and 1 is 4, and the difference between 1 and -2 is 3. So this point passes the test and is therefore on the circle. The distance between -1 and 1 is 2. So it's not going to give us a 3, 4, 5 triangle. So this point is not on the circle. 3, 2. The distance between 3 and 1 is 2 units. So this is not going to work. What about 4, -6? The distance between 4 and 1 is 3. And the distance between -6 and -2 is 4. So this fits the bill. 5, 1, the distance between 5 and 1 is 4. And the distance between 1 and -2 is 3. So this one also works. So this, and this are points on the circle.